Okay, Honors Chem, we are going to talk about mass percent today. So I just want to talk about a couple of ways that we can look at percent. Now, you've probably been doing percent since about fourth or fifth grade. So most of the time, your teacher probably talked about looking at the part that you were interested in or wanting to know about divided by the whole thing. And then you would take it and multiply by 100. And you always put that funny percent sign by it. I want to just look at the word here. Per in Latin means of or from. So we can think of this as of or from. And then cent. We use cent a lot. So how many cents are there in a dollar? 100. Centi, how many centimeters are there in a meter? 100. So cent means 100. So we're looking at how many out of 100 we would expect to be this thing. That's what percent means. Okay? So just a little etymology of the words here. Now, knowing the formula for a compound, we can really readily calculate the mass percents of each of the constituent elements in a compound. It's convenient to start with 1 mole of a compound. Okay, so our first example, we want to find the percent. We can also sometimes put the mass percent in here of each element of sodium sulfate. Now, the very first thing we need to do is find the molecular mass. So we need to look at each of the atoms in that compound and how many we have of each, and then grab our periodic table. So let's look at each of the atoms we have. We have sodium, and we've got 2 of them. So I'm going to need to multiply whatever sodium I have by 2. I've got sulfur, but I've only got 1. So I just need to look up that mass. And then oxygen, I've got 4 of them. So I need to multiply whatever I have for oxygen by 4. So let's look up our periodic table. And remember, when we look up masses on the periodic table, we want to look at masses to the nearest hundredth. Okay, we're going to round to the nearest hundredth. So we are going to look up our various elements here. So sodium, we have 22.990. So to the hundredth, that is going to round up to 22.99. So let's put that on here. 22.99. Looks like I flipped over too quickly. Sulfur. Let's look up sulfur. We have just 1 sulfur. So sulfur is 32.066. That's 6 in the thousandths place is going to tell us to round to 32.07. So we're going to round sulfur to 32.07. And then oxygen, remember we had 4 of them. So let's look and see how many oxygens or how much oxygen weighs. So oxygen, 15.999, that will round to 16.00 for my mass. 16.00. So we're going to add all of that together. So you're going to want to have your calculator handy. So when I do that, let's see, 2 times 22.99 plus 32.07 plus 4 times 16. Now remember your order of operations here, guys. Okay, that's really important. So our total mass ends up being 142.05 grams per mole. Okay? Now, to find the mass percent, we want to look at each constituent element. So we're going to look at sodium first. Sodium, we've got 2 of them, and our mass was 22.99. So we're going to look at it this way, part divided by the whole. So what is the whole? The whole of the molecule is the molecular mass that we just calculated. So we're going to divide by 142.05 and then multiply by 100. So if I take 2 times 22.99 divided by 142.05, and then multiplied by 100, I get 32.36888. Now, I don't want all of that, so I'm going to go to the hundredths place. So that 0.368, that 8 is going to tell me to round up. So I'm going to call this 32.37% sodium. Okay. Now for sulfur, we're going to do the same thing. Sulfur, we've got 32.07. We're going to divide by the whole mass of the molecule. Then we're going to multiply by 100%. So 32.07 divided by 142.05 multiplied by 100%. We get 22.576. That 6 tells us to round up, so we're going to call that 22.58% sulfur by mass. And then oxygen, we're going to take our 4 oxygens and divide that by our total mass, 142.05, and multiply that by 100%. So when we take 4 times 16 divided by 142.05 multiplied by 100, we get a mass percent of 45.05% oxygen. Okay, now, if you want to check, all 3 of these, when they add up, should add up to 100%. Okay, now, is there another way that I could have gotten the mass of that last element in the compound? Since all 3 of those percents should add up to 100, could I have taken 100% and subtracted my mass percent of sodium as well as my mass percent of sulfur to give me my mass percent of oxygen? Would that work? Yeah, that would totally work. Now, the reason I didn't do it that way, though, let me show you a pitfall. What if I made a mistake on one of these 2? If I made a mistake on one of these 2, wouldn't it inherently give me a mistake here? Yes, it would. So, to keep myself from making other mistakes in calculations, I do it the long way just to make sure that things are, more accurate. Because, in science, it is all about accuracy. All right, number 7. I want to find the percent composition of each element in scandium-3 nitrate. So that 3 right there tells me that scandium is a +3. And if I look on my polyatomic sheet, hopefully you guys all have a polyatomic sheet handy. Nitrate is NO3 -1. Okay, now the next thing we've got to do is figure out the ratio. How many scandiums do we need and how many nitrates do we need when we put them all together for the sum of the charges to equal 0? I like to find the least common multiple between the charges. So the least common multiple between a 3 and a 1, right? That's a -1, is 3. So how many scandiums do I need to get to a +3? I need 1 of them. And how many nitrates do I need to get to a -3? I need 3 of them. So we are going to need 1 scandium, and we're going to need 3 nitrate groups. Okay? Now our molar mass, let's set it up like we did before. I have 1 scandium. I have, let's see, 3 times 1 will give me 3 nitrogens. And I have 3 times 3. That gives me 9 oxygens. So we need to look at our periodic table now to find the masses for each of these. So let's look. Scandium, 44.956. That's going to round to 44.96. So 44.96 for scandium. Nitrogen, let's take a look at nitrogen. Nitrogen, 14.007. That's going to round to 14.01. Okay, my scandium didn't keep. I moved too quick. And oxygen, we already looked up before, right? We know that oxygen is 16.00. So we're going to add all of that together. So 44.96 plus 3 times 14.01 plus 9 times 16. You should get a molar mass of 230.99 grams per mole. Okay, now I think percentages are pretty easy, so I think you guys can do this. So take a minute, pause the video, calculate your percent of scandium, nitrogen, and oxygen, and check back in just a minute. Okay, you ready to check? So scandium, you should have 44.96 divided by 230.99 multiplied by 100. So when we do that, we get a mass percent of 19.46% scandium. Okay? Nitrogen, you should have 3 multiplied by 14.01 divided by 230.99 multiplied by 100%. That gives you a mass percent of 18.20% nitrogen. Now, if you notice, I'm always taking these mass percents to the 100th. So we're just going to do it to the 100th. And then for oxygen, we're going to have 16.00 times 9 divided by 230.99 multiplied by 100. This gives me 62.34% oxygen. Okay, so here's our formula for mass percent. It's pretty easy. It's pretty self-explanatory. You guys have been doing this since 4th or 5th grade. All right, have a great day. We will talk about empirical formulas next and molecular formulas in our next video. All right, bye.